We are a company focused on empowering engineers to use artificial intelligence and machine learning to solve intractable physics problems, always with the goal to get products to market faster. So we're building, in short, a coding-free cloud software where you have a wealth of machine learning models specifically targeted towards engineering problems. And our goal is always to try and understand complex systems, right, to reduce time, cost, or increase modeling accuracy, classic engineering problems. If you're not familiar with our software yet, you can picture it as a workbench for engineers. There's plenty of tutorials on YouTube and on our website where you can learn more about it. It's packed full of algorithms specifically designed for research and development problems and scientific machine learning. What we really like doing is we really like looking at such complex algorithms and packaging them up so they become more easily usable for domain experts. So for today, if you are a battery electrochemical expert and you always thought, I'd like to learn more about how I could use data science to solve some of my problems, that's exactly the kind of thing that we do. If you have fairly big data or you sit in a big complex organization, working with bigger data on the cloud is complicated, we have a solution for that as well. We're building this fully cloud enabled with AWS and have been doing this for, I think, 6 years now. And so if you have a look, there's hundreds of projects where this has been done before, from Formula One to rocket engineering, and plenty of big engineering companies already use this. We've been doing this so long that we started clustering engineering applications, like AI applications engineering, into specific groups. And so it usually always starts with 80% of data science is getting the right data. Everyone who's ever done a data science project knows this. And so one of the most useful suites that we offer here at Monolith is what we call a test data validation suite, where we use unsupervised machine learning models to help you automatically sanity check and validate your sensor data. It's really useful to get faulty sensors, sensor drift, sensor dropout, or essentially just checking whether all of your tests give you the same result. Do they check out against each other? And so the first thing, if you do data science in engineering, is help engineers check whether they have good quality data. The next thing is that in engineering, we work with hardware. And that means if I want any data, I need to go test this thing at some point in the real world. And then when you test in the real world, the question is, what test do I need to do? If you test too little, you don't know enough. If you test too much, it becomes very expensive and slow, and somebody else might beat you to market. And so one of the other critical things everyone needs to solve is test plan optimization, where it's all about, what do I test? What do I not test? How do I create this super efficient validation test plan to learn everything that I need to know to minimize quality issues, maximize performance, and get this thing out to market? Once it's out to market, or sometimes even before, you will encounter an error, an issue, a reliability issue, a quality issue, a manufacturing issue, and you don't really understand why. And so in our experience, the majority of work that data scientists do when they get hired by a large engineering company is root cause analysis, where they get a huge amount of data from a product. Like, here's everything that we know about our printers. They don't work, figure out why. And then you need to go through the design parameters, the material parameters, the manufacturing parameters, and everything else, and try and figure out which of those parameters was the one that caused the problem. Did we record it? And I like saying that if the needle is in the haystack, so if you recorded the problem with your sensors and with your spreadsheets, then Monolith will find it. Last but not least, classic engineering. Once you've understood it, you've predicted it, you've gotten rid of issues, it's time to optimize. And machine learning is very good at optimizing very complex nonlinear dynamic systems. Plenty of research has been going on in this area by the world-leading research labs, where you're really trying to figure out how I can calibrate something very complex to work in a lot of conditions. Like on the extreme spectrum here, you have autonomous drones, autonomous cars, but you don't need to take it that far. There's other things where you can build a controller for BMS to understand SOC or SOH, to extend your range, extend your lifetime a little bit beyond what you originally had.